Okay. Hi guys, welcome to High Entropy. It's day 78 of DSA learning, and so far, very good morning to all of you whoever is gonna watch it now or in future. So if you are gonna watch it in future, then I'm from the past, and if you are watching right now, I'm your present. Yeah, I don't think I can say like I'm your future because it definitely either past or present. By the way, let's how are you doing, guys? Okay, let me open my screen. So it's yeah, I don't think I can see like that. Let's see. It's day 78 of DSA, and I will start with some dry diagram. Day 78. Let me use my glasses, otherwise I won't be able to see the things, and you won't be able to see me. Okay. So it's day 78, and so far what we learned. Yesterday I was trying to solve a problem, and I thought like whatever approach I have used in the past, it will be like we have to use same approach, but it was little different. So that's why when you are solving, when learning from that video, it's like learning. Don't stick to a particular approach. Think out of the box because there are people used to say like there are few patterns, but still I feel like there are multiple patterns. It could be two pointer approach, it could be any other approach, simple scanning from one end to another end. But yeah, still there are some patterns definitely that will help you to solve most of the problems. Think out of the box because DSA somewhere I feel like okay, it's not something where there is any limited number of types. Every time some, for example, I was solving the lead code problem, though it feels like it can be solved using the longest increasing subsequence, but it is failing. You can solve it, but it's like when you are, it's not an optimized approach. So yes, you have to come up with new ideas, new approaches, especially in DSA. uh, Come up with new approaches because that's about what exactly they wanted to test out. It's not like they just want to see whether person is able to solve the problem or not. Okay, because and also it's about time, how you are coming up within the time, whether you are able to think or you are taking lot of time. So definitely, if I have to let me think about what are the challenges that I'm facing right now. I will list them down and will try or I'll try uh, to fix them or maybe to overcome them, not fix them because fixing is something that is not uh, quickly. Oh, I'm not changing. Sorry. So yeah, I thought so. Yeah, so here if you see day 78 learning, we don't stick to a particular approach. Think out of the box. DSA come up with new approaches, and here learning our outcome. Learning from the past experiences. First thing, don't panic. This is biggest problem. Like whenever I'm appearing in any exam or in any assessment or if the coding exam, I always start panicking if I'm checking the problem, if I'm not able to solve it, I start panicking and maybe I will come up with uh, bad approach or maybe with lot of boilerplate code. And I noticed it in the last uh, lead code weekly contest 509, I believe. Okay, so don't panic. This is one thing. And second, think out of box. Still, I'm giving it more preference because think out of box. There aren't any fixed approaches, so you have to come up with things, come up with out of box. And second, third is practice. Practice plays a key role. Practice, like we need to practice lot more. Then only you will be able to solve. And fourth is, I okay, three and fourth is regular, or you can say consistency. It's very important. Only practice is not important. Like suppose you are doing for 2 days in continuous, or then you take 5 days break. It won't work. Our brain is it's easy for our brain to what do I say? It's easy for brain to forget the things because there is lot more things, and there are some things that are in priority, so it won't store them if they are not necessary, right? And you can't remember thousands of problems or hundreds of problems. I if I talk about me personally, then I can't remember them, for sure. So this is one thing. Alright. Okay. So let's now jump and solve problem for the day. It's not a problem for the day. Let me first stop screen mirroring. I don't want. Done. What happened to it? Why it is showing in different pane? Let it be. No problem. Okay. So let me jump to take you forward and let's see how it goes. So we are solving LIS. Definitely we are in the challenging problems now, right now, because we solved the basic problems and so many different type of problems. So let's jump and see how it goes. Okay, let me do one thing. I will create a new board. Better butter. It's a day 77 DSA. Okay, so we are in dynamic programming. Okay, after that I will jump into graph. I will follow the same order because graph is also the one thing. Maybe I will. There is trees, right? No, but I will start with. I will jump into graph. I know basics of tree, like how to use in order traversal, pre-order, post-order. So I think I will be able to learn it because graph I never learned or never solved problem. Maybe I solved one or two, not more than that. So definitely it is the most important one. And linked list I solved problem. Recursion we are already solving. Stack and queue I solved some problems. String trees also I solved some of the problem in the. So definitely this one and this one, these are the two things that I never practiced a lot. So oh, I don't need to click it right now because right now we are solving DP. DP is the most important one, and it plays a key role in our programming solving practice, because sometimes we are not able to come up with simple approach. Longest increasing subsequence. What is the difference between this? Longest increasing subsequence, DP483. Is it the same problem? No, I don't think. Given an integer array nums, return the length of the longest strictly increasing subsequence. Okay, 1 minute bro. I'm just thinking about, given an integer array nums, return the length of longest strictly increasing subsequence. A subsequence is derived from by deleting some numbers elements without changing the order of remaining element. For example, 3627 is a subsequence of 0. If the task is to find the length of longest subsequence in which every element is greater than the previous one. Example: 10, 9, 2, 5, 3, 7, 101, 18. Output char long I mean 4. The longest increasing subsequence is 2, 3, 7, 101, and its length is 4. Okay, I wanted to see this 0, 0, it's 2 times, so definitely 0, 1, 2, 3. Now you're doing okay. Correct. By the way, okay. So first thing that comes into my mind is what's the difference between this one and this one? And yeah, this problem and this one. What is the difference? Longest increasing subsequence. This one is also the same, right? Given an integer number, return the length of longest increasing subsequences. Every element is greater than the previous one. And here, oh, it's same. Submissions, let me see. Why they, if it is the same, then why are they giving it? Okay. Let me think again. Actually, I solved it, but I don't remember the solution for it. One option was last. I was using, I remember. So if you are solving, let's take it as a revision. LIS. So what exactly we were doing? Approach 1, recursion. Okay, let's see how much time complexity or time constraint. 10 to the power 5 and length of number 10 to the power 6. So that means approach 1, simply what you are doing at each step you are checking if you can take, if you can take number or not. Yeah, at each step you are doing this. Suppose you started from starting. So at the starting you don't have anything in the back, so you can say -1. Then you can start. You have two options: take or not take. Other than that, like for each element, like you move to this, or maybe you haven't took it and you move to this. Now if you are moving to this and you haven't took, then it will be last will be -1 only, and if you took it, then last will become this one. So what you are going to do, you are checking at each step if you can take it, if based on the past decision or based on the past number, and you are taking it. So this is recursion problem. You can solve it using recursion. Another approach is where you are just trying to minimize the recursion or number of calling stack, because you can do it with order of n square, where you are creating a table, and another is you are memoizing it. But the problem is, even if you are taking an array to solve it, still you are using two loops, so it's like order of n square. Okay okay so it won't work. Actually I tried it wasn't working. So another option is like here we are using binary search. I don't know why it is called binary search. Yeah, I got it, why it is called binary search, because we are applying binary search only. So let's take example. Let me take an example. So I have given 0 1 0 3 2 3, 0 1 0 3 2 3. Okay, these are the numbers that are given. So actually, I just memorized it. I'm just trying to uh, memorize it because it's completely new to me and I don't know. So at starting, this is the example array. What you will do, you will say okay, zero. You kept zero, okay, because so far this is the number that is the part of it, and you can say okay, this is the longest number. Now you took one, so one is bigger than the last element. You will say okay, I can take it because still it's these two are the longest one. Now again you got zero, so you will say okay, zero can be part of it, but where it is exactly fitting into the array. Okay, so you will say okay, it won't fit here and it won't fit here. It will fit here. So you will say okay, if I'm replacing it, it will become 0 1. Cool. So it will still remain 0. Now you got 3. 3 is bigger than this, so you will add it at the end. Now you got 2. Okay. So you added 2. You will say okay, let me add 2. So 2. 2 is bigger than this and it will fit into somewhere here. Lower bound. So 2 will come somewhere in between this. You will try to find 2. If you are not able to find 2, then what you will do, you will say okay, what is the real location where it will fit into the existing. So you will say okay, it is bigger than this, so it will fit here, say, somewhere. Okay, you kept 2. Now you are getting 3, so you will say okay, let's see about it. So 3, you will say okay, 3 is bigger than this, so 3 will fit here. So now you will get longest subsequence 4. Okay, what is the length of the array? So if I have to analyze it, what exactly we are doing? First thing is we are scanning each element, then we are placing the element in the sorted array. Okay. Let me take another example. Actually, I'm looking for clarity, more clarity on it. It's like I got the solution, but not the intention. Why? How to come up with this approach? Where is the color? So first thing is we have example 10 9 2 5 3 7 101 18. 10 9 2 5 3 7 101 18. Okay. Oh, I forgot to add the timer. So let me add clock, and it should be 1 hour 40 minutes, let's say. Yeah. So first thing, you will say okay, let me build the array. So at starting you will say okay, I have 10, so yeah, it will be part of it. Then you got 9. So if you are taking these two numbers, or maybe so far, what is the maximum length that you can achieve? Either you will take 10 or 9. So definitely now you will say okay, if I have to place 9, where it will fit. So say, imagine this is the, you can say in this array this is the smallest, so you will fit it 9 here. Now you are checking 2, so you will say okay, let me check 2. If you are going to take 2, 2 9 10, so definitely 2 is the smallest number out of this, so definitely you will take 2, then only it will be part of LIS, right? So you will say okay, let me take 2. Then you got 5, so 5 is bigger than 2, so you will say okay 5. Now you got 3, so you will say okay 3 can be part of our array are part of our LIS. But if I am taking 3, where exactly it will fit into the existing uh, LIS? So you'll say 5. It's definitely it's not 5. So it should be somewhere before 5. So okay, you thought okay, let's do one thing. It should be before 5, or it should be somewhere in. So you said compare with 2. No, it's bigger than 2. So you'll say okay, compare with 5. So you'll say okay, it's 3 and 5. Definitely one will occur, either 5 and it will say 3. 7, you got 7. Now you got 101. 101 will remain here. Now you got 18. So 18, now you will compare 18. 101, it's bigger than, smaller than this. 7, bigger than this. So definitely lower bound will be this. So you'll say 18. Now it will be like 4 conditions, 4 elements. So what I'll do simply, I already solved it yesterday only. I think, yeah, day before yesterday I believe. Yeah, printing if we were. So we have LIS, we have array, len of nums. So what I'll do, LIS result will be like this. So what exactly we are doing? For I in range n. Or len of, or you can say result of -1 is less than nums of I. That means this number is bigger than the last number, or it's still result array is empty. So you'll say okay, let me append nums of I. Yeah, definitely you don't need to check lower bound, you can append it. Else what will do, LB will be the index of lower bound, and you will say self dot lower bound, and you will pass the nums array and element, or and nums of I, and you will get lower bound. So what you will do exactly, so you will say result of LB, this is nothing but index, and you will say nums of I, you are pasting there, or you are overriding it. So if you notice one thing, if you are replacing in between somewhere, it is coming before it, either last element, you seeing some pattern here. Whenever you are including new number, so let's say 7, so 10 9 2 5 3 7, so 10 9 2 5 3 7. So at a starting you have 10, then you got 9, so 9 will replace 2, 2 will replace 5, 5 will replace, or 5 will append after it. Hmm. 10 9, if I'm taking a smaller number, that means length is giving the maximum LIS, but you cannot assume like this is the actual LIS, because you can get the length but not the actual LIS. So yeah, that's what I was thinking. So we replaced, and finally you will say return len of LIS. Okay, let me define a function. Define self low bound self, and then you will give nums and el. So start will be 0, end will be len of nums minus 1, and here while start less than equals to end, you will say mid is nothing but start plus end by 2, and once you got the mid, then you have to check if mid equals to start no, mid equals to el. That means okay, you got the return. Hey, return mid. This is the index that you are looking for or you are returning. Else, if sorry, nums of mid greater than, if nums of mid is less than element, so you will say start is equals to mid plus 1. Else you will say result equals to and end equals to mid minus 1. Where is index? Out of bound again. No. I think I did one mistake here. I need to pass result array, and in the result array only. I do lot of mistakes. Wait a minute, result mid equals to EL. Array I will use. I used. So it's kind of revision that I did. Okay, let me jump to another problem, then I'll get more idea. MCM, definitely I'm gonna refer Aditya Verma's video. Okay, next is largest divisible subset. Yeah, it seems interesting one. These are medium difficulty problem. Okay. So okay, given an array nums of positive integers, the task is to find the largest subset such that every pair A and B. Okay, given an array nums of positive integers. Okay, the task is to find the largest subset such that every pair A comma B of elements in the subset such that every pair of elements in the subset largest divisible subset every pair A percentage by B equals to 0 or B percentage by A equals to 0. That means every number is divisible by each other. Correct? Yeah, I think so. No, it's I think I'm sure, because suppose there are like A, B, C, D. So you are saying. Let me first uh, grab the think what I'm thinking. I mean, let me visualize it. Try to try to visualize it, because the thing is, here we have given an array number of positive integers. Array, it's like a positive integers. Okay, now what exactly we need to do? So we need to find a subset where, let's say this is a subset and it contains A, B, C, D. These are the four numbers that are given. Now I need to do one thing. First, let's try to find out the pair. So you can say A can be paired with B, A can be paired with C, A can be paired with D, B can be with C, because A and C we already took. B can be with D, and C can be another one. C can be with D. So these are the different pairs that are possible. Now if you see A and B, that means A and B are divisible. So definitely A and C are divisible. So every number is divisible by other number. A with B, A with C, and A with D. B with C, B with D, C with D. So I think we are covering almost everything. Okay, wonderful. Now the thing is king. Thing is king. So given an array of positive integer states, note as there can be multiple correct answers, the compiler returns one if answer is valid, else zero. What do you mean? Okay, so it does not matter. Subset. Okay, just our goal is to return subset in any order. If there are multiple solutions, return any one of them. You don't need to care about whether solution is the exact matching. You are not checking the, or you are not comparing the results. You are just checking whether it is a feasible solution or not. So okay, it looks good. Now the thing is how I'm going to approach this problem. Let's take 3, 5, 10, 20. These are the no, yeah, these are the numbers. So here what I'll do, I'm expecting, let's take 3. Can 3 be part of subset? Then what is the one thing? Largest we need to find, right? So let's say we have two options, take 3 or not take. Okay, so if you are taking 3, Then what are the options? You take took 3, you are not taking 3. Now you have 5. Can you take 5? You will say no, cannot take 5 because uh, 5 is not divisible by 3. So okay, you won't take 5. Now you will jump to 10. Okay, let me use some better notation. Better, better notation. You took 3. No, no, it's not good. You took 3. You haven't took 3. Now, now the second option is 5. So here you are saying you took 5, and here after taking 3, can you take 5? No, you cannot take 5. Cannot take 5. Okay, now after 10, you will say 10. Can you take 10? Definitely, if you are not able to take 5, then definitely, okay, not definitely, then you will say 10. 10 also you cannot take. Then you will say 20, because if you are not taking, then there isn't any option to explore further. 20 you cannot take. This is one option. Another, you took 5, you haven't took 3. So after 5 you have options 2. You took 5. Okay, 5, 10, 20. But what if there is 5 and then 15, 20 and 30 and full? Then your decision matters most. It's not like if you took 5, that means you can take 20, 30. But if you are taking 15 as well, then you can take 20, 30. But if you are taking 5, 15 and 20, will it be possible? No, because 20 is not divisible by 15. So definitely it's not an, like you will end up with either 5, 15. So here and there. How will I compare it? I mean, you took 5. Another option, you are not taking 5. Second, I mean, you take here, you are not taking here. Now second thing is you may move to 10. Again you have two options, 10 take, not take. Here after 5 you are not taking, then you have option 10, taking, 10 not taking. But how to make sure that number is, question is here only one, how to make sure the number the number that you are taking Suppose here I'm just thinking, let's take 5, 15, 20, 30. 30. So first you took 5, then you have two options. 15 you are taking, and another one you are not taking. So you took 20. Okay. Because 5 and 15 are divisible. So it's a perfect combo. And when you are taking 20, right now if I'll compare 15 and 20, definitely they don't match. Okay. What if I'll sort the number? Can it solve the problem? Sort the number. If I'll sort the number and then check only the last. For example, here 5, then 15, then 20, then 30. So if you'll say, okay, 5 is divisible by 15. Now if you'll say 15, for 20 you are checking. So you can say 5 is divisible by 20 but not by 15. Hmm. One thing I got it. Suppose whenever you are building a chain, if the numbers are sorted, then one thing will be there. For sure, that is property of it. If A, now you are getting B, now you are deciding for C. So if A is able to divide B and C, now we are picking C only if C is able to divide B. So C is bigger than this number. So for sure you can say if B is able to divide C and A is able to divide B, that means A will be able to divide C as well, right? So and B and C are already dividing. And let's say D. If C is able to divide D and B is able to then definitely B will be able to divide C, because if C bigger number is able to divide it, and then it's this smaller number, and this one also will be able to divide. So what I think, not I'm thinking, but it's like this is one approach that is coming into my mind using dynamic programming, using the DP approach, where what I'll do simply, I will consider, I will take last element, and based on last, if the current element is able to divide it, or if I'm able to divide it, suppose I will take consider last, and now if current percentage by last equals to 0, then only you can take, else you have option simply not take, and it's similar to that. So let's see the time complexity, how much it is going to be. 10 to the power of 3. That means I can take order of, okay, so I can use something. Can we use hash set instead of sorting? So I'm not sure about hash set because I think I never used it in the way, but sorting definitely will help in this way, in this approach. So okay, now let's write the recursive solution first for it. So step 1, sort the array. And now step 2, to base case. If uh, index equals to n, that means you already covered all the elements, so return 0. Okay. Step 3, that is normal condition. So if last, the element that you picked in the last, so what I'll do, instead of taking the last element directly, what are we going to do? Okay, if last equals to, so last we are storing index. So okay, one challenge will be here. Nums of I can go up to 10 to the power 6. Okay, if it is going up to 10 to the power 6, that means array size will be 10 to the power 6. And if I don't have last, what does it mean? It's a first element. Hmm. 7 14 settings. Obviously, this is the example 7 14 28. By the way, let me think about it. Can we take 10 to the power 6 plus 1 and it won't be overflow? It won't be, because I want to take index of number. Oh, wait. I mean, this is the number. Number can be up to 10 to power 6. But if the length of array is this, then that means whatever the array that we are gonna take, its index, what is the last element? So 10 to the power 3 only. Okay, it's okay. Otherwise, definitely. One more thing, if I will take the array of 10 to power 6, definitely it will be overflow. Like it will cause the time TLE. It will be a TLE. Okay, and the reason is simple: 10 to the power 6, irrespective how much array size you are taking. 10 to the power 3, number of element into 10 to the power 6, it will be 10 to the power 9, and 9 will be like TLE only. So what I'll do, if array of last is equals to percentage byte, I will say like this, because the array is sorted. So array of index equals to percentage by array of last equals to 0. That means this number is divisible. So option 1 take, option 2 not take. Else when you are taking 1 plus take, let me use now memory I have. So I will use something like solve index, another thing will be array, length of array, and memory. Anything else I need to do? Last, it will start with -1. So again we are going to use pseudo index here. So first thing, return 0 simply. Now if I'll say name of index and last, we already stored it greater than equals to 0, return this one. Third option, not take. I'm taking that one first. So not take means you will say solve, okay, index plus 1, you are moving to next in array element, array will remain array, n will remain n, memory will remain memory, and last will be remain last also, because you are not making any change. If second option, so I'll do this, take equals to 0, and if array, if last equals to -1, okay, or here I'm going to do this last plus 1 we are storing. Okay, if last equals to -1 1, or even I can start with 0 only. Yeah, it's better if I'll start with, let's leave it, it does not matter. So okay, last equals to -1, or array of uh, index percentage by array of, you will say last plus 1, last is not this, yeah, so it will be last only, equals to 0, then you will say okay, no problem, return, not return, take is will be 1 plus solve, and here you are going to say index plus 1, and last will be, I'm keeping everything same, and array of I, or you will say not, we are storing index, so index, and finally you will say return, first store return max of what, take, not take, so let's solve it using both approaches. So I will do it using simple approach. First thing is I'm going to take memory, let me store an n is nothing but len of nums. Okay, so we have n. Now just think about it, like how many elements will be there, it could go up to n, 0 and n. So number of columns n plus 1, so -1 for underscore in range n plus 1, and you don't need to take for underscore in range n, because you are returning, so return self dot solve, and here you are going to say index will be 0, and another thing is, okay, let me define function first, define solve self, and here you are going to give index, and second thing is n you are giving, last you are giving, and mem you are giving, array you are giving, and mem you are giving. So if index equals to n, return 0. That means you already processed all the elements, so the maximum length, that maximum you can say length of divisible subset you will be 0. If it is not the case, then you will say let me check in memory if it is already available. So you are saying index. Okay, now last you are taking from -1, so last plus 1 greater than equals to 0, then you will say return mem of index and last plus 1, because you are storing this in such a fashion. If otherwise you are saying not take is equals to self dot solve and so okay, if you are not taking, that means index plus 1 will become n will remain n, last will remain last, and array will remain array, mem will remain mem. Perfect. If another option, if you wanted to include this element, then if last equals to -1, then you can consider it. Or if array of, not this, if array of index, okay, let's say, yeah, array of index, not index, index percentage by array of last element. You wanted to see the last element, so last could be -1, that you are taking care. If this is not the case, then that means it will be actual index of the element. So last equals to 0, that means it is divisible by this number. So return, I forgot to sort the array. No, not take will be something. First, this you are including this number. You are solving index. You are moving to moving forward, because definitely you are gonna process next element. Index n, last will be, you will say current index, last array mem. Now, okay, just placeholder take equals to 0. Now you have take and now take. So now you will say mem of index, first thing, last. Okay, it will be last plus 1, because you are stored. And here you will say okay, no problem, max of take, max of not take, and take. Okay, you got this. Return mem of index plus, okay, one thing I just want to optimize it. Because if you already calculated, why to calculate it again? Use the, like you are accessing again element, so it will take time, right? And today array return result. Perfect. Now this is perfect one. So okay, this part is done. The only pending part is this one. So we are giving index, we are giving n, we are giving last -1, array we are giving, and we are giving memory. These are the things that we are passing. But before it, also we need to sort the array. I'm sorting it in place. So is it good or not? Sort. Let's see. Okay, let's do one thing. Oh God, I need to store the result, right? It's not like I need to give the wow, very funny. Then I think this problem will be little challenging using the recursion because you have to store everything. So okay, let's jump into second approach. Say let's this is our table. Every time you are doing like here it will be 0 0 0 0 0 0 0. What exactly you are doing at each step. So I and J, just you are checking last. Okay, based on that you are taking take or not take, whichever you are getting maximum. So you are moving to that option. Okay, one thing you I need to do. So now you are at this step, and every time you have two options. Either you are moving, definitely you are moving to next element. This is for sure. Z in range. I will say n minus one. No, no, no. When range 0 to n minus 1, 0 to n plus 1 means up to n. If j minus 1 equals to minus 1, or j can be up to what? Not n plus 1. If you are talking j about j, then what are the last steps that you have taken so far? It can go up to 0 to I minus 1. So definitely it's like up to I. So array of I, you will say okay. So array of I, definitely. Hmm. I am writing not in the right way. What if I tilt it? Yeah, j equals to minus 1, that is last element, that means last is minus 1, so you can take it. So these are the two decisions that you need to take equals to 0 and starting, and second thing is array of I, this is the bigger element, and now you are taking decision with last. So percentage by array of last, so last is starting from this to last minus 1 equals to 0, then take equals to 1 plus, and you will say table, and here you will say I plus 1, and here you will say last will be j, not j, I. This is the new last. Not take means whatever you have table I plus 1 and z will remain z. Okay, one more thing here, you are taking I, so I will be not be the exact index, it will be I plus 1, and here last is not last but it's j. Okay, now these are the two things that you are doing. Now I want to construct the solution or answer for it. If I will start from here, I'm just thinking, then I have options like okay, first I took this or not, maximum, if it is maximum then I will take it, and if not maximum, max of both, whatever is maximum you will take that, and then you will move to another step, another step, and until you will end up till here, become this. So let me solve it. So first thing is table, first thing is I need to calculate n. Okay, let me close it first. N will be length of nums. Okay, you are taking the length of nums, now you are creating a table, everything let's fill it with 0, 0 for underscore in range n plus 1, that is nothing but the, you can say last value index, pseudo index you can say, because minus 1 you are keeping it as a 0, and 0 you are keeping it as a 1, and underscore for underscore in range n plus 1. So you got the table. Now your task is for I in, you are starting from bottom to up, range n minus 1 to minus 1 and minus 1. I, you are going from 0 to I. Okay, now you will say okay, you have two option, not take, simply that means you are not taking 0 plus what, table, and you will say I plus 1 because you are looking for the next element, and here if you are not taking j, you are not taking I as an element, so you will say okay, j will be remain same j. And second, if j minus 1, that is equals to minus 1 last, or if, or you can say array of I percentage by array of j will become j minus 1, because j is not the real actual index. Array of j equals to 0, then take will be 1 plus array of, not array, table of I plus 1, and here also I plus 1, that is not current index, and here I will take equals to 0. Also I need to do one more thing, sort. So here you will say array is nothing but uh, sorted nums. So I got this. Okay. So far I have these things. Now I need to take result is equals to, or you will say table of I and j equals to max of take, not take. Okay, you got this. Finally, you have the, you have constructed the array. Next thing is you need to find out the result. So result will be empty at starting, and now you will say I equals to 0, j equals to 0, and while I less than equals to less than n and j less than n. If so, now you have two options. You have two options always. Like how to decide where to move or where to navigate. So you will say take, that means you are taking the element, and if you are taking, you have conditions. So okay, I don't think I need to check which one is the, just I will say take will be something, take will be, okay, table of I uh, taking. If you are taking the index, that means you are moving to I plus 1. Okay, if you are taking, that means your j will become I plus 1, and not take. If take greater than not take. Okay, that means you will take, okay, you are taking the element, so result dot append, and you will say what you are appending. J the is nothing but I plus 1. So I will become I plus 1 and J will become I plus 1. Else, that means this is not the case, so not take part is okay, bigger. Then you will say you are not taking this element. Okay, so you will move to next element and you will say, okay, you haven't took this element, so I equals to I plus 1 and J equals to J. Always getting 0. Let me print the result first. Somewhere something is wrong. 20, 5, 10, 22, 32. Last element only you are appending. First let me see the print table. I think table is culprit or what? Okay, so starting 0 0, 1 0 0, 1 0 0, 1 1 0. So table is incorrect only. The first problem, table is incorrect. So that means logic is somewhere failing. So when say take for J in range I. Hmm. 3 5 10 20. 8 16 32. Okay, it is okay. I in range n minus 1 minus 1 minus 1. J in range I less than I. Not take means you are not taking, and then simply 0. Table I plus 1. That means you are moving to next index, next element. J J will remain the last element because you are not taking it, so last will remain last. Okay, now another option. Take you are taking. If J minus 1 equals to minus 1. So this is the first element. So now definitely you have two decision, take or not take. If you are not taking this, this is the condition. If you are taking, this is the condition. Take or array of I, current element is divisible by array of j minus 1 equals to 0. So j is representing for these indexes and j minus 1 will be, okay, the actual index that last you pick. Wow, yeah, what's wrong? Take not take. 32 divisible, 232 divisible, 432 divisible, 832 divisible, 1632, 216, 164. Somewhere some part is doing I plus 1. Oh god, how to debug it now? So like construct the tree, not tree, the numbers 3, 5, 10, 20. Everywhere I see only 1, 1, 1. Nowhere it's. That means LIS I'm not able to get it from it. Longest divisible subset. Okay, largest divisible subset. So what could be wrong? Let's construct it. So how many elements are we here? 3, 5, 10, 20. That means we need 3, 4, 5. I'm starting with good and I'm ending up with bad. 0, 1, 2, 3, 4. That means 3, 5. Okay. And here we have 0, 1, 2, 3, 4. At index 0, all are 0. When we are talking about 3, 3 means 0, 1, 2, 3, 20. For 20, what will be the last? If last is minus 1, then okay, now you have two options. Either take it, if you are taking it, okay, now let's start filling it. So for 0, z equals to minus 1. Now you have two options, take or not take. If you are taking, then 1 plus, and another thing, and j will be I plus 1. And reason is simple. I plus 1 means pseudo index of j. So for example, for 3 it will be 4, because 4, and here so let's see. So for this 3 it will be 4, 4, and also you are going to check not take 0, so definitely it will be 1. Now for 1, if you are taking 1, last index is 1. 1 means 0. Okay, 1 means 0, you are taking last element as 3. So definitely if you are your last index is 3. Okay, if your last index is 3, that means you will compare, can you take it or not. If last is 3 and current index is 20, so 20 is not divisible by 3, that means you cannot take it, so it will be 0 only. 0 from here, 0 from here, or 0 from here and only, so 0. And now you will say okay, no problem. Another option, last is 2, 5. I mean 2 means 0. 5. So 5 is divisible by 20. So you'll say okay, 5, if you are taking last as 5, then you have two options. One, you take it 1 plus and this one, and here you are keeping this one, fourth, so it will be 1. Now again for 10, if it is 10, you are taking last element as 10, 10 divided by 20, so it will be 1. Okay, and what we are getting here, and another option, 4. 4 means, can we take 4 till it will go till I is 3, so 3, 3 minus 1, okay, so it will go to 3. One doubt I have, just it's like I plus 1, you to go till I plus 1. See, now I'm getting something better. You can see 3, that is okay. Now this is one issue that I was having. Result is somewhere something missing. One number is missing somewhere. So first is 5. Equals to n z. See, I mean making mistakes, so many mistakes. God help me. Wow, what's wrong? Fuck. What the heck it is taking? 4, 36, 36, 37, 52, 59. Somewhere traversing is wrong. I can see like the result is correct, but it should be 3 only. Okay, let me do one thing. If we talk about 3, how did we get it? No, yeah, it's not what I'm expecting. "24 minutes for Q. You are taking 2 hours." God. Whenever you are getting result of I and Z, it is based on two options: take, not take. Okay. Oh, okay, okay. You are taking every time, like whenever you are taking, if take equals to greater than not take. No. is equals to I plus 1, 1 plus one thing. For each element you are taking two decisions. Take means you are doing one thing. You have two elements. One is like whenever you got this result, you got it from table I plus 1. Okay. Equals to I plus 1. Okay, so it seems like all are equal. If I take, so somewhere problem is there. I plus 1 z. What I'm missing, bro? Let me watch the tutorial. Fuck. My logic is
Okay, we
failing.
will be solving the problem. Largest divisible. Either array of I should be dividing array of j or any answer. Here lies a possible thought process. Since they're saying print any answer, and we're looking for divisible, we need to we need to convert this problem into somewhere related to longest and subsequent, because we know in dynamic programming is one as my first die, I'm taking one as my first die, rule by one. Because 4 is divisible by 1. So 8 has to be divisible by 1. Understand the intuition. If 4 is divisible by 1, and if 8 is divisible by 4, so the why? Because 8 is divisible by 4, which is big thing, has to be divisible. Has to be divisible. So if you remember the code for LIS, if you remember the code for LIS, you know, so if I just rewrite the code, it was something like I equal to, it started from 1 because at the same time we said if dp of I, whatever it had was lesser than if I take this element, because I take this element to be plus 1. If it is, then you went on and said dp of I will be dp of j. You check for this and that's how you sort the hash. Now I'm changing the question to divisible. Once the array is sorted, change the question to divisible. You just need to check for divisibility. So can I say divisible? Then I just need to check for the length because I'm looking for the longest. This is how the length of the unit. Slight subtle change, and I can convert an LIS question to an LDS, which is the longest divisible subsequence. Makes sense, guys? So once you've done this, you can definitely any answer it works. But the key point, the longest increasing subsequence in order to print it, this is how we did. We basically took up a vector TP and basically just copy paste this. It's the same code, it's the same code. So I just copy paste this in the divisible set question. So just copy paste it. So if you remember, this is the DP and this is the hash, and initially the maximum was 1. I've taken the exact same code, exact same. What I will do different is, I will say, I will sort that. Okay? I will sort that. Nothing different. I just sort that. Once I've sorted this, instead of this, I will say if array of I modulo array of previous is equal to 0. If this is true and this is kind of true, then this is what I write. And in this way I can store it. And this will make sure the subset is stored, and I can reverse it, and I can just make sure divisible by 4. 8 is divisible by 4. So every pair is divisible. I'm not saying that 8 has to be divisible by 16. It can be either way. 16 is divisible by 8, that's okay. So that is the meaning of divisibility. That's the meaning of divisibility. So I need to find the largest. So I can say if I just format this, which will be the largest divisibility pair, then I'll be like, I can pick one. Like if I pick up an element array of I and array of j. So either array of I should be dividing array of j, or either array of j should be dividing array of I. It should satisfy either of these conditions. For an example, if I pick up a subset like 16, 8, 4, this is a subset. Now what can be all, like, what all pairs can I have? I can have 16, 8 as a pair, I can have 16, 4 as a pair, I can have 8, 4 as a pair. Like I can have 16, 8, I can have 16, 4, and then I can have 8 and 4. Right? So these are the 3 pairs that I can have. Now if you carefully see, 16 is divisible by 8. 16 is divisible by 4. 8 is divisible by 4. So every pair is divisible. I'm not saying that 8 has to be divisible by 16. It can be either way. 16 is omit this, which will be the largest divisibility pair. Then I'll be like, I can make 1, 16, 8 and 4. This is indeed the largest divisibility pair, because if I write down the pairs, 1, 16, 16 divides 1 for sure. 1, 8, 1 divides 8 for sure. 1, 4, it's still divisible. 16, 8, divisible. 16, 4, divisible. 8, 4, divisible. So I can say all the pairs are divisible. Okay, so if all the pairs are divisible, this can be a possible answer. And if you add a 7 to it, This will not. Why? Because if you add a 7, the 7 is not divisible by 4, 8, 16. So you need to be very sure that each of the pairs are divisible, which are in the subset. So divisible question, divisible you have understood. Now about largest. You have understood this is the largest. This is of size 4. And you cannot have any greater size subset. Now the question states the array that you are given will have distinct numbers. The array that we will have distinct numbers. Okay, that is for sure stated. And also another statement is given to you that you can print any answer. Since we're talking about subset, you can print 1, 16, 8, 4. You can jumble it up and print like 4, 8, 1, 16. Or you can also print it like 1, 4, 8, 16 in the sorted fashion. You can print any of the answers. And if they're dividing each other, you will be getting a AC, which is correct answer. Alright? So that is what the problem is all about. Now since they say, so print any answer. Here lies a possible thought process. Since they're saying print any answer, and we are looking for divisibility, we need to convert this problem into somewhere related to longest increasing subsequence, because we know in dynamic programming it's generally the subsequence where we deal with indexes and then we decide whether to pick or not pick. We generally do that. So can we relate this to somewhere around longest increasing subsequence? I'm like, how? I'll tell you. What if I take this example and I try to sort it? Because since I can print any answer and the order does not matter, even if I sort it and I try to find out an answer, it's still okay. As long as the divisibility is not compromised, I'm still okay. So I'll be like, okay, straight. Let's really sort it, because it doesn't matter. Even if I sort it, whatever answer I get, like even if I get 1, 4, 8, 16, it's still okay. Okay, fine. Now, how do you make sure that each of the pairs are divisible? Like, how do you make sure that 1 divides 16, 1 divides 8, 1 divides 4, and then 16 divides 8, 16 divides 4? Can we have a shortcut? Now, since I have sorted it, again, please hear me out properly. Since I have sorted it, okay, if I'm picking 1 as my first guy, and the next guy I'll pick up 4, and the next guy I'll pick up 4, okay? And then I say that, hey, listen, 4 is divided by 1, right? So if I'm picking up 8, the next guy, because I cannot pick up 7, because 7 cannot be divided by 4, this is not possible. But can I pick up 8? Why? Because 8 is divisible by 4. Can I see this? If 8 is divisible by 4, which eventually means that 8 is also divisible by 1, because 4 is divisible by 1, so 8 has to be divisible by 1. Understand the intuition. If 4 is divisible by 1, and if 8 is divisible by 4, so the rule also follows that 8 will be divisible by 1, right? Okay, next I come to 16. Now can I see, when I come to 16, and 16 is divisible by 8, which indirectly means 16 is divisible by 4, and 16 is divisible by 1 also, due to the sorted, because I've already checked for the divisibility of 4 by 8, and divisibility of 1 by 4. So I can easily say 16, if divisible by 8, means that divisible by all the elements in the array. So I can say, I can easily pick up 16. So did you find the pattern? Did you find the pattern? You did. Whenever I'm picking up 16, since the array is sorted, I'm definitely sure if 16 divides 8, like if 16 is divisible by 8, it will be divided by all the other picked up elements. Why? Because 8 is divisible by 4, which eventually means that 16 is divisible by 4 as well. So the rule. So you can try out another example that you see. So I got this. So can I say, now I'm looking out to figure, like can I just think this question as, once I've sorted the question, am I looking out to figure longest subsequence, and can I say divisible subsequence instead of increasing? Am I looking to figure out the longest divisible subsequence? And answer to that is yes. Why? Because 4 divided by 1, 2. 8 divided by 4, 2. 16 divided by 8, 2. Right? Prior to this, we were solving the problem, which was increasing, like we were taking 1, 3, something like 5. This was longest increasing subsequence. Can I relate this problem to longest divisible subsequence? Instead of increasing, I'm making sure the next number that is being taken, has to be divisible. So if you remember the code for LIS, you remember. So if I just rewrite the code, it was something like I equal to, it started from 1 because 0 will be not there, I lesser than I plus plus, and if you remember there was a j loop which was from 0 till I, and you went on to j plus plus, and since it was increasing, you said if array of j is lesser than array of I, because you're saying array of I, LIS, plain LIS, and at the same time you said if dp of I, whatever it had was lesser than, if I take this element, because if I take this element it will be plus 1. If it is, then you went on and said dp of I will be dp of j plus 1, and you said in the hash of I, you can keep j because that's where the dp would have been derived from. This is the if statement. This is the if statement that you wrote, and then the for loop executed. So if you remember, this was the LIS. If you remember well, this was the LIS code, and the LIS code you check for this, and that's how you stored the hash. Now I'm changing the question to divisible. Once the array is sorted, change the question to divisible. I just need to check for divisibility. So can I say, because I know the array is sorted, So can I say, what I just need to do is, I need to cut this guy off, and I know array of I is greater. So if array of I is divisible by array of j, then I can say it's divisible. And then I just need to check for the length, because I'm looking for the longest. This is how the length of dp will go. Slight subtle change, and I could convert an LIS question to an LDS, which is the longest divisible subsequence. Makes sense, guys? So once you've done this, you can definitely use the hash array to track back. Yes, you can use the hash array to track back your longest increasing, so longest divisible subset. And since you need to print any answer, it works. But the key point over here is you need to sort the array, because if you don't sort the array, the logic does not bind. Like 16 is divisible by 8, and that means 16 divisible by 4 by 1 binds because it is sorted. Got it? So I hope you have understood it. So without wasting any time, let's check out the code. So if you remember in the longest increasing subsequence, in order to print it, this is how we did. We basically took up a vector TP and basically let's copy paste this. It's the same code. It's the same code. So I'll just copy paste this in the divisible set question. So just copy paste it. So if you remember, this is the DP and this is the hash and the definition of the maximum is 1. I've taken the exact same. Exact same. What I will do different is I will say I will sort.
This is one approach, but I don't know, yaar. Very bad. Stuck into it. No, I won't ask ChatGPT. Fuck ChatGPT. Okay, let me try different approach that I tried to print LIS. Uh, 3, 5, 10, 20, 16, 8, 2, 4, 30. Okay, now what I'll do, so DP. DP will be something where we are storing the number. So for each at starting will be 1, maximum length 1. Like you are considering only that particular element. It will be 0, 1, 2, 3, 4. let's say now I'm just sorting it. Definitely it will be something like 16, 8, 32. रुक जा भाई, नहीं हुआ। टाइम के अलग जा रहे हैं बहन चोद, कोई मतलब नहीं निकल रहा है डीएसए सॉल्व करने में वैसे तो। 16, 2. 2 can be part of it, you will say 1. Okay, yeah. Now 4 can be part of it, you will compare it with the last element. So if you are comparing 4, then dp will be like, okay, no problem, you will say 4 and 2. So here it will be something like, okay, 4 plus 1, 4 and 1, dp of 1, so 1 plus 1, 2, it will be 2. And here you will say what is the index of dp of 2, so you will say, okay, take the 1, 0. Now 8, 8 you will say, okay, oh yeah, this is example, bad example. 3, 5, 10, 20. शूट या बैंड शो, ये भी नहीं काम कर रहा है। सिद्धू कट गया। 3, 5, 10, 20। ओ भाई मारो मुझे। 3, 1, 1, 1, 1, 0, 1, 2, 3. Okay, now what I'll do? 3. You consider 3, so 3 is this. Okay, 1 it will be. Now 5. Can it be part of it? So you will say no. It cannot be part of it. It's not divisible by this, so dp will remain same. Now you will say 10. 10, can it be part of it? 5. So you will say yes, it can be. Yeah, no, it's not working. 10 simply be part of 5, so 5, 10 divisible by both, then you will say okay, it can be part of it, so you will say dp will become 2, and here index will become uh, the last index of it. 20, 10 divisible by 10, so you will say okay, what is the dp of it? 3, it will become 3. Now you will say okay, no problem. Here you will say this is nothing but dp of this, so 2. Print 3, you will jump to 2. Second index, what is it? Second index is 0, 1, 2, 10. Intuition is still failing, man. Oh, okay. Let me stop it stream. Bye bye guys. Everything ruined up. Why my face is visible or not visible? I think internet is fucking mother. MC it's yeah, see. You can see speed. I don't know what they are doing and why they are. Bye guys.